So what is the actually power, and how can you be able to find the power? By the way, if we say a power simply means the rate of change of the work done per unit time, or is said to be the work done per unit time. That's what you call the power. Let's say we have the object and are being subjected to the force given as F, and assuming that the object has been displaced and out of some distance, let's say d, and within the time given as, let's say g. So according to the principles behind, since the force has caused the object to displace, then the work has been done given as force times distance, of which the work has to be given in joules, as you already know. Now, the work has been done within the time period given as t. Then if that's the case, then the ratio of the work done with respect to the time given as the work done over time, then we have it as a power, which is basically given in watts. Can also be given in kilowatts based on the nature of the question, but that's how the power can be expressed. And with the further analysis, the work done is given as the force times distance over time, and of which you should have to understand that if we have, let's say, AB divided by M, this is the same as having it as, and that should be B times A over M. It is the same. Or likewise, it is the same as, let's say, B over M, and that times A. It is the same as that. The law of algebra is two more that keeps on holding. So in this case, this is the same as the power is equal to, and that should be force times distance over time, and of which distance over time corresponds to the velocity or speed. So which means we have force times the velocity. This is also another formula for the power you can think about. So if you have the force as well as the velocity, can be able to have that we call the power using that formula. And the velocity has to be given in meters per second. The time has to be in seconds as well. So keep that in mind. Let's say this is the question. Now, to pass a slow-moving truck, you want your fancy 1,500 kg car. Now we have the mass. Which is given as 1,500 kg. And that will accelerate from 13.4 meters per second. That's the initial velocity. 13.4 meters per second. And we have the final velocity, which is given as 17 point, and that should be 17.9 meters per second. And we have the time, which is given us, and that should be 3 seconds. Let's have that. What is the minimum power required for this actually pass? You should have to understand that since we are having the aspects of time and some sort of velocities, then since we have the aspect of time here in this case, you should have to understand that the power will be given as the work done divided by time, of which how should you have the work done? So the work done will be calculated using the work energy theorem. So you'll be able to have the work done using the work energy theorem, which says that the total work done is equal to final kinetic energy and minus the initial kinetic energy. That is minus initial kinetic energy. So try to have that and substitute it there. Now also let's consider this actually problem. The way we have it as it takes a force of should be 1450 newtons. That is the force. Should be 1450 newtons. And now to keep, now we have the mass, which is given as 1300 kg per car, but we should have the force of 14,500, and that should be 14,500. I wrongly recorded this. But I should be 14,500. Should be 14,000. Let me have it here. I should have it as 14,500 newtons. So it should be that. And this is the mass of the car giving us that. So now, of course, we've been given the slope, which is the angle theta, but let me just have to highlight it as well. Angle theta given us 5.25 degrees. Now, if the engine delivers, should be the weight, should be the power. And what is the power? 4104 watts. Then now, what is the speed? What is the speed in this case? Now, in this case, you have to understand that the power is giving us the force times the distance. So, which means we have the power and we also have the force. We'll be able to have the speed in that way. You should have to understand that the mass will not have to be used, and also the angle theta won't be used because the object is moving actually along the slope of 5.25 degrees. Because the thing is this, it is like the object is trying to climb onto something. The car is moving, climbing on something. So we're not much interested with the angle itself. No, we're just being interested to look at the force that is being applied and that is making a car to move, and also to look at the power itself, and that is making the object to move in that case. So we'll have to find the speed using this formula, and of which the force has to be the applied force. We not have to regard about the weight of the object, where you may think of resolving this into components, where you may think of resolving the weight of the car into components in some aspects. So just have to literally use the given information, disregarding the mass as well as the angle theta. So keep that in mind. So which means we just have to substitute the power and also the force, and that will have the corresponding, and there should be the speed there. So now let's say we have this question. A small motor runs a lift that actually raises a load of bricks weighing, and that should be 836 newtons. That is the force. We have 836 newtons, and we have the distance, which is being expressed as h, 10.7 meters, and we have the time given us, let's say 23.2 seconds. Now we should have to calculate the power the actual model must produce. So how should we have the power? So now, according to the given parameters, the power will be given using the formula given as work done over time. So you can be able to have the work done using the first times distance, and the time it is the same as this. So that's how you can have to have the power which the model must have to produce. So there are several questions you should have to come across with on the power. So you just have to go through some questions, and wherever you have problems, you just need the responses or the comments in the description section below. You just have to see where you are struggling with. Thank you.